Hello guys, welcome to the next class of limits. In the last class, we discussed about the series expansion of the important functions log 1 plus x, e power x, sin x, cos x, tan inverse x, a power x, and 1 plus x raised to power n. And we discuss how do we use this series expansion to prove one of the previous formula, limit x tend to 0 sin x by x. And one important thing I told you that till what term you have to expand, you need to expand up to that power of x which you see in the denominator, because all the higher powers will automatically become 0. So we'll continue from here now. Next we'll discuss few examples on series expansion. Let's start. First we have limit x tend to 0 sin x minus x over x cube. So pause the video, give it a try. Let's start discussion. So answer for this is minus 1 over 6. If you haven't got this thing, see now. So sin x minus x over x cube. So we can expand sin x here. Like I told you, you need to expand up to x cube only because all the higher powers will automatically become 0. So just to show you again, I have taken three terms here. So x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. Minus x as it is divided by x cube. You will see that this x and this x will get cancelled out. Then you cancel out x cube from numerator and denominator. You will get minus 1 over 3 factorial plus x square over 5 factorial and so on. So all these terms, when you put x as 0, will be 0. What we are left with only minus 1 over 6. I hope it is clear, guys. Next problem. Next we have limit x tend to 0 tan x minus sin x over x cube. Pause the video, give it a try. Let us start discussion now. So answer for this problem is just 1 by 2. You can see here we have limit x tend to 0. In the denominator we have x cube, so we expand tan x up to x cube, sin x up to x cube. So it will be x plus x cube by 3. This is x minus x cube by 3 factorial divided by x cube. So x and x will get cancelled out. Then x cube get cancelled out in the numerator and denominator. We are left with only 1 by 3. This minus minus become plus. 1 by 3 factorial will become 1 by 6. So 1 by 3 plus 1 by 6 will be 1 by 2. So answer here just is 1 by 2. Next problem. We have limit x tend to 0, 1 by x into 8 plus x raised to power 1 by 3 minus 1 by 2x. It's a good problem. Give it a try, guys. Let us start discussion. The answer for this problem is minus 1 over 48. See, what you can do here is we have 8 plus x. I take 2 common out, like 8 common out. And when you take 8 common out from cube root, it will become 2 outside. So 2x, 1 plus x over 8 power 1 by 3 minus 1 over 2x. This 1 plus x over 8 power 1 by 3 we can write in the numerator as 1 plus x by 8 power minus 1 by 3. Denominator will be same in both of them then. We get 1 plus x by 8 power minus 1 by 3 minus 1 by 2x. Now here 1 plus x power n expansion we can use just up to x only. So it will be like 1 plus nx. We don't need to take next term because in the denominator we have x only. So all the next terms will have x square, x cube. We can skip that. So 1 plus nx will become 1 minus x by 24 minus 1. So this 1 and 1 get cancelled out, x and x get cancelled out, we get minus 1 over 48. I hope it is clear, guys. Next. Now this next problem is a very, very important problem. These kind of things they ask in mains, sometime in advance also. Limit x tend to 0, a sin x plus b x e power x plus 3x square by sin x minus 2x plus tan x. I think this limit is equal to L. L is a non-zero finite number, so then find the value of a, b and L. Okay, this is same L here. So if L is non-zero finite, then find the value of a, b and L. Okay guys, give it a try, then we'll start discussion. Let's start now. The final answer, those who have solved, you can check here. The final answer is A is equal to 3, B is equal to minus 3, and L is equal to minus 12. If you have got this thing, you can go to the next problem. Otherwise, see the solution here. First of all, we just use expansion here, and first we see in the denominator we'll have sin x, which is x minus x cubed by 3 factorial minus 2x, and tan x will be x plus x cubed by 3 factorial. We will see that this x, and 2x get cancelled out. So in the denominator, the minimum power of x will be cube. X cube by into 1 by 3 minus 1 by 3 factorial. Okay, next terms will be x power 5 something something and so on. What you do is just take the minimum power of x, whatever is there, and same you use in the numerator. So minimum power of x in the denominator is x cube. So in the numerator also you have to expand up to x cube. Higher powers will not be required because they will become 0. So numerator also you expand up to x cube only. So first of all, sin x, we expand up to x minus x cube by 3 factorial. See, bx e power x. So when bx is outside, that means inside you have to expand up to x square only. Because final thing should be x cube. And if I take x square into x, it will become x cube. If you take up to x cube, when you multiply with x, it will become x power 4, which will be of no use. So expand e power x up to x square by 2 factorial. Last 3x square as it is. Now when you combine x terms, x square term, x cube terms, we end up with x into a plus b, x square into b plus 3, x cube into b by 2 factorial minus a by 3 factorial. Divide by x cube into 1 by 3 minus 1 by 3 factorial. This is equal to L. Now, if you want L to be a finite non-zero number, what should happen here? The x cube should get cancelled out. And how will you get x cube cancelled from the denominator when coefficient of x and coefficient of x cube numerator must be 0? See, if this thing becomes 0, this thing becomes 0, then we can cancel x cube, no? So, coefficient of x, that is a plus b, that should be 0. Coefficient of x square, that is b plus 3, must be 0. So a will come out to be 3, b will come out to be minus 3. And when that happens, then this will be 0, this will be 0, we will cancel x cube and x cube. You see here. X cube will get cancelled out, we get b by 2 minus a by 6, divide by 1 by 3 minus 1 by 6, that is equal to L. So now you can put the values here. So b is minus 3, a is 3, when you put it here, you get minus 12. So final answer is L is minus 12, A is 3, B is minus 3. I hope it is clear to all of you guys. Next. Next we'll discuss some miscellaneous problems on sequences. The first one is this. We have limit n tends to infinity 1 plus 1 over 5 into 1 plus 1 over 5 square into 1 plus 1 over 5 power 4 up to 1 plus 1 over 5 power 2 power n. You can see that in every bracket the power of x is getting doubled. In the first bracket you have 5 power 1, second we have 5 power 2, third we have 5 power 4, next will be 5 power 8, 5 power 16, and last is 5 power 2 power n, where n tends to infinity. You can give it a try, then we'll start discussion. Let us start now. So answer for this problem is 5 over 4. If you have got this thing, you can go to the next problem. Otherwise, see what we can do here. In this problem, the triggering step here is multiply and divide by 1 minus 1 by 5, which will be basically 4 by 5. So multiply with that and divide by that. So when you divide by 4 by 5, it becomes 5 by 4. And this 1 minus 1 by 5 I'll use here now. See, if I take this and this term, it's like a plus b, a minus b, it will become 1 minus 1 by 5 square. If you multiply this and this, it will become 1 minus 1 by 5 power 4. Multiply this and this, become 1 minus 1 by 5 power 8. And finally, it will become 1 minus 1 by 5 power 2 power n plus 1. Basically, in every step, the power of 5 is getting doubled. So finally, end up with 1 minus 1 by 5 power 2 power n plus 1 into 5 by 4. When n tends to infinity, this will become 1 by infinity, which will be 0. So you get 1 minus 0 into 5 by 4, which will just be 5 by 4. I hope it is clear to all of you guys. Next problem. Next we have limit n tends to infinity pi r3 to n of r cube minus 8 by r cube plus 8. I hope you know, like, pi means product. So we'll put r from 3 to n and multiply all those terms. So give it a try, then we'll start discussion. Let's start now. What do we have here? R cube minus 8. We can write as r minus 2 into r square plus 2r plus 4 using aq minus bq formula. In the denominator, you can use aq plus bq formula, which will be r plus 2 into r square minus 2r plus 4. This r square plus 2r plus 4 I can write also as r plus 1 whole square plus 3. And r square minus 2r plus 4 I can write as r minus 1 whole square plus 3. Now we take these two terms separately. If I take pi r3 to n of r minus 2 into r by r plus 2, they are in product only, so I'll just find the product of these term, find the product of these term, and then multiply them again. So find pi r3 to n r minus 2 by r plus 2. See, when you put r as 3 here, we'll get what? We get 1 by 5. Basically, we just focus on the numerator first. We put r as 3, we get 1. Then you get 2, then you get 3, 4, 5. And last will be like last term will be n minus 2. Previous will be n minus 3, n minus 4, n minus 5, n minus 6. In the denominator, when you put r as 3, you get 5. Next will be 6, 7, 8, 9. And last will be n plus 2, n plus 1, n minus 1, n minus 2. What you will see there right now, the difference between them is 4. So if you write the terms in the numerator, you see 1, 2, 3, 4, 5. So the terms get cancelled from 5. So these first 4 terms will be pending here. Then all the terms will get cancelled out. But till what point? Here the last term is n minus 2. So this last n minus 2 will get cancelled with n minus 2 here. So what terms are pending here? N minus 1, n plus 1, n plus 2. Simply what you can see here is the difference is 4. So first 4 and last 4 terms are pending. First 4 will be in the numerator 1, 2, 3, 4. Last 4 in the denominator n minus 1, n plus 1, n plus 2. I hope it makes sense. Now the next part here. Here it is r plus 1 whole square plus 3, r minus 1 whole square plus 3. If you see the difference between these, r plus 1 and r minus 1, the difference here is 2. So when you put r as 3, you get 4 square plus 3, 5 square plus 3, last will be n square plus 3, n plus 1 square plus 3. In the denominator, it will be 2 square plus 3, 3 square plus 3, last will be n minus 2 square plus 3, n minus 1 square plus 3. So what you will see here is the first term in the denominator is 2 square plus 3, 3 square plus 3. Next will be 4 square plus 3, which get cancelled out. So what you will see here, difference between these two was 2. I'm not talking about the square right now, just r plus 1 and r minus 1. If you see, the difference is 2. So the first two terms in the denominator are pending. So finally, last two terms in the numerator will be pending. Because this term is n square plus 3, so previous will be n minus 1 square plus 3. It get cancelled out with the last term of the denominator, which is n minus 1 square plus 3. So this last two terms of numerator will be pending now. So it will be n square plus 3, n plus 1 square plus 3, divided by 2 square plus 3, 3 square plus 3. So when you multiply these two, you get left with these terms only. So we get limit n tends to infinity 1, 2, 3, 4 by n minus 1, n plus 1, n plus 2, n square plus 3, n plus 1 square plus 3 by 2 square plus 3, 3 square plus 3. In the numerator, we have a degree 4 polynomial. Denominator also we have degree 4 polynomial. So we discuss infinity by infinity form, two polynomials of same degree. The final answer will just be the leading coefficient. So leading coefficient in the numerator will be 1 into 2 into 3 into 4, which is 24. And leading coefficient of denominator will become this thing, which will be 4 plus 3 is 7 and 12, which will become 84. So 24 by 84 will become 2 by 7. So final answer here is 2 by 7. I hope it is clear to all of you guys. Next is Sandwich theorem. What is Sandwich theorem? They say if we have a function fx, it lies between gx and hx. Then limit x tend to a fx will also lie between limit x tend to a gx and limit x tend to a hx. And in a particular scenario, let us say limit x tend to a g of x and limit x tend to a h of x comes out to be L. Then limit x tend to fx has to be L only, no? You might feel that this is greater than this and less than this, how they can be equal. But the problem is we are talking about their approximate values, not the exact values. So limit x tend to a gx, let us say it is 1, but in reality it will be like slightly less than 1. Hx might be slightly more than 1. Fx also will be like slightly less than 1 or slightly more than 1, but we are approximating it to 1. So in general, if we have limit x tend to a gx is approaching L, limit x tend to a hx is approaching L, so we can say limit x tend to fx should also be approaching L only. Okay, this is used for those problems where finding limit on fx is not possible. So we look for two functions which contains fx value. Like one will be more than fx, one will be less than fx. We'll put limit on those two, and from there you get the limit of fx also. Let us see with the help of example. So this first example I'll discuss here. We have limit x tend to 0, x into step of 1 by x. Now this is step of 1 by x. Solving this limit with any method we have discussed till now will not be possible. So what do we do here? We assume, let us say this limit is L. Now you know step x. See, step x will always be less than equal to x and more than x minus 1. This inequality is true for all x belongs to real number. Okay, we'll discuss this thing in the greatest integer lecture. So step of 1 by x will lie between 1 by x minus 1 to 1 by x using the same thing. Now we multiply x both sides. We multiply x both sides, x all the sides, and then take limit x tend to 0. So if I multiply x here, you get x into step 1 by x and then take limit x tend to 0. Multiply x here, you get 1 minus x. Multiply x here, you just get 1. When you take limit x tend to 0, you see this thing will come out to be 1. This thing is already 1. So if L lie between 1 to 1, it has to be 1 only, no? I hope it makes sense. So step of 1 by x lie between 1 by x minus 1 to 1 by x. We multiply x all three sides and then take limit x tend to 0. So directly we get this will be 1, this will be 1. So L has to be 1 only. Okay, now let us see the next problem. You can try this next problem yourself. We have f from R to R be a positive increasing function with limit x tends to infinity f of 3x by f of x equals to 1. Then find limit x tends to infinity f of 2x by f of x. Okay, can give it a try. Let's start discussion now. You see f of 2x, if f is an increasing function and x is some positive number, f of 2x will obviously be more than f of x and less than f of 3x. If x is some positive number and f is an increasing function. Now divide by fx all three sides and take limit. So this, when you divide by f of x here, you just get 1 only, limit x tend to infinity. And this is already given 1. So the middle one should also be 1 only. So the answer will just be 1. Okay, when we can divide by f of x and take limit x tend to infinity. Next problem. So we have limit n tends to infinity. Okay, this is n tends to infinity. Step of x plus step of 2x plus step of 3x up to step of nx by n square. This limit we have to solve. Give it a try, then we'll start discussion. Let's try now. Here we assume this limit to be L again and do the same thing here. Step x we can write between x minus 1 to x. So step of 2x will lie between 2x minus 1 to 2x. And keep on doing till nx, you get step of nx lie between nx minus 1 to nx. Now, so all of these are more than these terms, the left sides. So I can say the limit L should also be more than limit n tends to infinity, all these left side terms. So you get n x minus 1, 2x minus 1 up to nx minus 1. When you add them all, you get n into n plus 1 by 2 into x minus n by n square. You see this is a polynomial in n. The degree is 2 here. So answer will just be leading coefficient of numerator by denominator. So leading coefficient, the coefficient of n square here will be x by 2. And here it is 1 only. So L is greater than x by 2. Now do same thing in the right side. So we can say L will be less than equal to n tends to infinity. Now we take right side terms x, 2x, 3x up to nx. So what do we get? We get x plus 2x plus 3x up to nx by n square. Again, when you add them, you get n into n plus 1 by 2 into x by n square. And again, if you put limit here, you get x by 2. So L is greater than x by 2, L is less than equal to n by 2. From these two, we can say L has to be x by 2 only. So Sandwich theorem will be applicable whenever the limit on the left side and right side come out to be equal. Then only we can conclude L has to be x by 2. If they don't come out to be equal, then you have to think of some other method. Okay, guys, next one. Next is how do we solve one power infinity form? Okay, first of all, when I say one power infinity form, it is like this actually. It's limit x tend to a fx power gx. Let us say this is y. We say it one power infinity form when limit x tend to a fx is 1 and limit x tend to a gx is infinity. So basically, it is not exactly 1. It is just limit when you put x tend to a, it comes out to be approximately 1. Because I told you if it is exactly 1, then any power will be 1 only. So it is not exact 1, it's approaching 1. Okay, so you have to keep in mind. And this is approaching infinity. So we say it is 1 power infinity form Then how do we solve this thing? We have this trick here. We can write a power b as e power b ln a. A power b as e power b ln a using the properties of logarithm. If you don't know this thing, you can just look into the logarithm class. Properties of logarithm will be there. So using that, we can write this fx power gx as e power gx into ln fx. Limit x tend to a. You can take this limit in the power, you get e power limit x tend to a gx into ln. For this fx, I add and subtract 1. So get 1 plus fx minus 1. Why? Because we know the expansion of ln 1 plus x. So x here will be served as fx minus 1. So expansion will be gx outside. It will become fx minus 1 minus fx minus 1 square by 2 and so on. Okay, using the expansion of ln 1 plus x. And what happens here is, you see fx is tending to 1. So fx minus 1 will be tending to 0. So these terms usually will be too small. We can neglect them. So taking only first term of the expansion, we get gx into fx minus 1. So y will be equal to e power limit x tend to a gx into f of x minus 1. So we just taking the first term of expansion. So whenever you have one power infinity form, you can directly use this thing. We'll say if we have limit x tend to a fx power gx, we can write this as e power limit x tend to a gx into f of x minus 1. But what we are doing here in the backdrop is we are using this procedure, and here we taking the expansion of ln 1 plus fx minus 1, but we are taking only first term of that. Now, most of the problems will be solved by this formula directly. Most of the problems. But in some problems, after using this formula also, you will get some indeterminate form. After using the formula also, we still get indeterminate form. So in those problems, we'll have to use this proof here. So basically what happened in those problems, we can't take only first term, we'll have to take more terms. Okay, when to use that and when not to, we'll see with the help of examples. Like I told you, first use this formula. If you get a finite or if you get a determinate number, then that is a final answer. But if you still get indeterminate form, then we'll have to use this procedure here, what we have done. Okay, we'll see with the help of examples, guys. Let us start. First, a very simple example I'll discuss here. We have limit x tend to 0, 1 plus x raised to power 1 by x. You can see here, if I put x as 0, you get 1 power infinity form. So we just use the formula directly. We say it will be limit e power limit x tend to 0 fx minus 1 gx. So 1 plus x minus 1 into 1 by x. So 1 and 1 get cancelled out, x and x get cancelled out, you just get e power 1, which will be e only. I hope it is clear, guys. Let us try the next problem now. Try this next problem yourself once. We have limit x tend to 0 tan of pi by 4 plus x. Once again, tan pi by 4 plus x whole power 1 by x. Give this problem a try, then we'll start discussion. Let us start discussion now. So answer for this problem is e square. Those who could not solve, see this thing, guys. When you put x as 0, it will come out to be 1 power infinity form. So direct formula e power limit x tend to 0 fx minus 1 into gx. This you can expand here using the formula tan pi by 4 plus x. It will be 1 plus tan x by 1 minus tan x minus 1 into 1 by x. Now when you take LCM, you come out with get 2 tan x, and when you take LCM, it will come out to be 2 tan x by 1 minus tan x into 1 by x. So I'll just rearrange here. So take 2 outside, take tan x by x, and 1 by 1 minus tan x as it is. So limit x tend to 0, tan x by x will be 1, and here if you put x as 0, we also get 1 only. So final answer will just be e square. I hope it is clear, guys. Next. So give this third problem a try. Limit x tend to 0, sin x by x raised to power sin x by x minus sin x. Sin x by x raised to power sin x by x minus sin x. Give it a try, then we'll start discussion. Let's start now. Again, you can see 1 power infinity form. The final answer is 1 by e. If we haven't got this thing correct, let us see now. You can write this thing as, again, e power limit x tend to 0 fx minus 1 into gx. When you take LCM, here you get sin x minus x by x. Here sin x by x minus sin x. So this sin x minus x minus sin x get cancelled out, you get minus 1. Sin x by x will become 1. So it will just become e power minus 1, which will be 1 by e. I hope it is clear, guys. Next problem. This next one is an important problem from mains point of view. They do ask these kind of things. Limit x tend to infinity, p power 1 by x, q power 1 by x, r power 1 by x, s power 1 by x, divide by 4, whole power 3x, p, q, r, s are greater than 0. And you can say not equal to 1. That exponential function thing. So give it a try, guys, then we'll start discussion. Let us start now. So the final answer here is PQRS raised to power 3 by 4. We could not solve. See, guys. Again, you will see it's 1 power infinity form. When you put x as infinity, what you will get here? You get p power 0, which will be 1, 1, 1, 1. So 4 by 4 will be 1, and this will be infinity. So use the formula e power limit x tend to infinity fx minus 1 into gx. When you take LCM, we get minus 4 here, which you can split. We can write p power 1 by x minus 1, q power 1 by x minus 1, r bar 1 by x minus 1, s power 1 by x minus 1. This 3 by 4 you keep outside, and this x you can write as 1 by x and split all the terms. So it is supposed to be 1 by x here. So now when x tends to infinity, 1 by x will tend to 0. So like you see here, you get q power 1 by x minus 1 divided by 1 by x. We can use that thing, no, a power fx minus 1 by fx. When fx tend to 0 will be nothing but ln a. So same thing here, this thing will just be ln q, this will be ln p, ln r, ln s. So 3 by 4 ln p plus ln q plus ln r plus ln s. This will become ln pqrs raised to power 3 by 4, which will just be pqrs raised to power 3 by 4. Again, just using the log property. If you are not clear with log properties, look into the class of logarithm. Next one, guys. Now, this is the problem where we have to use the proof thing. See, we have limit x tend to 0, 1 plus x raised to power 2 by x divided by e square whole raised to power 4 by sine x. So all these are normal brackets. There is no step or anything here. Okay, just normal bracket is there. There is no step here. So you can give it a try. Let us start discussion now. See, the final answer here is e power minus 4. So if you have got this thing, you can move on to the next one. Otherwise, look into the solution. First of all, if you see this thing, if I take x as 0, what do you get here? You get 1 power infinity form. And when you solve this thing, you get E square. So if you put E square here again, you get E square by E square will be 1 again and raised to power infinity. So it again become 1 power infinity form. So overall, this is a 1 power infinity form. And 1 power infinity form, directly we use the formula, you get limit x tend to 0, fx minus 1 into gx. Okay, let us say this limit in the power is L. So I'll just be solving L here. So 1 power infinity form, we use the direct formula first, we get this thing. Now this limit I'm solving as L. Now, how do we solve this limit? See, you take LCM here, you get 1 plus x power 2 by x minus e square divided by e square into 4 by sine x. To settle this 4 by sine x and multiply divided by x, so this x by sine x will just become 1. Okay, leave it now. This 4 we can take outside and this e square we can take outside. We just get limit x tend to 0, 1 plus x power 2 by x minus e square by x. Now, this 1 plus x power 2 by x, if I use that direct formula here, 1 power infinity formula, we'll get e square, but e square minus e square by x will again become 0 by 0, no? If I use the direct formula here, you get e square, so e square minus e square will be 0, 0 by 0 will become again indeterminate form. So we'll not use the formula directly, we use the proof of that. What was the proof of that? A power b we can write as e power b ln a. E power b ln a, and then we have 2 by x ln 1 plus x. If I use the, like if you remember in the formula, we were just taking first term of expansion. But here what will happen is we have 2 by x outside. So if I take the expansion up to one term only, one term will be x. And this x and x get cancelled out, you will get only constant. Because outside we have 2 by x, if I just take first term, you get x. So this x will get cancelled out, we get a constant. What we do here is we have to take second term also. Because with this second term, outside x in x square will become x. And in the denominator also we have x. Like I told you, we expand up to that power of x which you see in the denominator. So if it was only ln 1 plus x, we could have taken x only. But because this 2 by x outside, we'll have to take up to x square by 2. So that x square by x will become x. So see here, you get 2 by x, x minus x square by 2 minus e square. Here when you take x inside, you get 2 minus x. Basically 2 by x, when you multiply here, you get 2 minus x. So from these two, we can take e square common out. And outside we have e square, will get cancelled out. We get 4 into limit x tend to 0. This will become e power minus x minus 1 divided by x. So multiply divided by minus 1, because if we have minus x here in the denominator also should be minus x. So this limit will come out to be 1. This is minus 1. This is 4. So L will be minus 4. L was in the power of e. So final answer is e power minus 4. I hope this problem is clear, guys. Otherwise, you can look into this thing again. This is very, very important for mains and advanced point of view. A similar kind of problem has been asked in JEE Advanced earlier. So do look out this thing again if you're not clear. Next, guys, next we have 0 power 0 and infinity power 0 form. To solve this thing, very simple method here. Just take limit equal to y and take log both side. Then use LH rule. That's all. Just keep two things in your mind. Take log and LH rule. Let us see with the help of example. Say we have limit x tend to 0 positive. Limit x tend to 0 positive x power sine x. When you put x as 0, you get 0 power 0 form. So we take the limit equal to y. So y equal to limit x tend to 0 positive x power sine x. And take log both sides. So log y will be limit x tend to 0 positive sine x into log x. Because when you take log, this power will come outside. You get sine x into log x. Now this sin x, you take in the denominator. I told you how to use LH rule. LH rule we can use only if we have fx by gx kind of form. So right now both the functions are in numerator, so I take one of them in the denominator. So we can write as log x by cosecant x. Limit x tend to 0 positive. And now we can use LH rule because it is infinity by infinity form. When you use LH rule, log x will become 1 by x and cosecant x differentiation will be minus cosecant x cot x. So this we can rewrite as cosecant x, we can write as 1 by sine, cot we can write as 1 by tan, we get minus of sine x by x into tan x. So limit x tend to 0 positive, sine x by x will be 1, tan x will be 0, so we get 0 finally. So log y is 0, that means y will be 1. That's all. So, like I told, take log both side and use LH rule. This is how you can solve every problem of power of form 0 power 0 and infinity power 0. Let us see next example. This example you can try yourself, guys. We have limit x tend to 0 sine x power 1 by x and plus 1 by x power sine x. Give it a try, then we'll start discussion. So the final answer here is 1. See how? If you see this part first of all, if you put x as 0, you get 0 power infinity. And 0 power infinity is directly 0. It is not indeterminate form. Keep this in mind. 0 power infinity is directly 0. So this we don't even have to solve. Second one, 1 by x power sine x, which will be infinity power 0 form. Second one, 1 by x power sine x will be infinity power 0 form. So here what we do is take equate it to y and take log. Get log y equal to this power come outside, you get sine x, and log 1 by x we can write as minus log x. Again log properties. So you get minus limit x tend to 0 sine x into log x. This limit we have solved in the previous problem also was 0. In the previous problem also we ended up with same thing. Limit x tend to 0 sine x into log x, which will be 0. So log y is 0, so y will be 1. So this limit is 1, this limit is 0. Final answer will be 1 only. I hope it is clear, guys. So that is all about the theory of limits chapter. So we'll have one more lecture I'll post in which I'll discuss some good problems on limits, some difficult advanced problems on limits.